Hi everyone, I'm Fanas, Product Manager for PTV Lines. Today I'll show you how to calculate ridership in your public transport model. Ridership numbers help you to understand demand and make better decisions, like avoiding overcrowded or underused services. I'll also highlight some exciting new features like improved cost calculations for different vehicle types and tools for creating informative maps of route revisions to share with passengers and decision makers. Let's dive in.
All right, let's dive into how we calculate ridership in PTV lines. First, I'll walk you through the methodology and then we'll jump into the software to see an example in action and evaluate the result together. Imagine you have ridership data in form of origin destination OD matrix showing travel demand between different neighborhoods. For example, in this example, we have a look at the three zones A, B, and C. Each neighborhood corresponds to a zone, is connected with the stops within their boundaries or overlapping their catchment area. This setup ensures that passengers in each zone are assigned to the most appropriate stop to start their journey. Now, let's say we are distributing passengers between zones A and C. We have few services as an option to choose. Option one, the pink line, which is a express bus. It has low frequency but has reasonable travel time. Option 2, the blue line, has high frequency but takes longer to travel. And option 3 is the combination of the yellow and green lines representing metro routes. This option has shortest travel time but requires a transfer at zone B. So, how do we calculate and distribute the passengers across the services? We consider factors like travel time, frequency, and the number of transfers. Transfers are especially important because they introduce walking and waiting times which are inconvenient for the passengers. At the end of the process, we calculate metrics like passenger kilometers or miles for each route. These are more precise than simply counting the number of passengers. We also look at the number of boarding and alighting at each stop, which helps planner to make better decisions about resource allocations. So let me show you how it works in the software. First of all, I want to show you an example. I have prepared an OD matrix for three zones. You can see 1, 2, 3. They're representing three zones in the south and the north and near to train station. And then, first of all, you need to upload the zone or stop data as JSON file, as a geometry, and then you can upload this CSV file or text file. We reference the OD matrix containing the zone IDs from 2, and then you can have number of passengers for different times. It can be one time during the whole day or even different days. In this example, we have peak time for the whole week, meaning that hourly we have, in this case, 950 passengers between 6 and 9 in the morning. So hourly 900 passengers traveling between zone 1 and 2. So let's see how does it look like in the software. So I have uploaded the OD matrix and the zones, and I can visualize them first of all. So the data that you have seen, the origin destination, I had three columns representing peak time and off peak. You can see that I have three zones here. One of them is in the south, the other one in the north, and this is near to the train station. And you can see by the width the number of passengers going to. So this is representing with the thick line here, the right side. So from south to the north, and this one is from the north to the south, and you can see the number of passengers traveling between zones. What we need is to define a demand model and calculate the distribution of the passengers on our network and on our services. For that, it's enough to go. You can see in the configuration, you have already origin, destination, and demand. I have uploaded my demand data here, my OD files, and I want to make a model from that. Give an appropriate name, and then you can choose for each hour, for each day, which value do you want to connect to. We have the morning peak is 6 to 9, so we just drag and drop. I allocate morning peak to this time, and then I have off peak time between 9 and 4 in the evening. And at the end, I have evening peak. So the meaning that the value that we had, 950 passengers from A to B or the other relations, are now allocated to time, for example, 6 to 7. All right. So I do the confirmation and I can back to this overview of my scenario and run the calculation here. I have already calculated. So what you can see is that as a result, we have total passenger kilometer versus total service kilometers and the ratio between them, which is showing the utilization of the services. So low ratio means that they're underutilized, and high ratio is it could be the overcrowded services. What you can also see is the ridership profile. If you dive into the each line, you can see the number of passengers and service kilometer, but also the ridership profile, which is showing the volume of the passengers between the stops for each line or each line route, and also boarding alighting information, which is saying that where the people are boarding and are alighting. So by this, you can recognize the main hubs in your services. Okay, just to understand the figures that we talk about, you can see here we have a SB line. This is a rail transit, has the highest number of passengers and passenger kilometer, followed by two tram, T2 and T3, for 6,000 passenger kilometer and 170 passenger kilometer. The reason is if you go into the detail, you can see easily that in the timetable. For example, here from the main station to the south, we need less than 10 minutes, where you need longer time like T2. If you check it, the main train station to the Moskaustraße, which is in the south, you need 20 or longer to travel. So people prefer to go faster and take the SB line. All right. Just imagine what happened if you do some changes in the network and in the service. For example, you have construction site, and we want to see the effect of the changes and the services and ridership. How do people behave and which lines they might take if we have overcrowding in the case of construction. For that, I just duplicate my scenario and do the changes here. I can let's say that the service is not available on Monday from train station to the west, and we need to block the services there. So what can we do is that we can shorten the line first of all. So just let's make a copy from the scenario from the line route we have, and then we can easily select the section we want to make shorter. By clicking on diamonds, I can select which part of the line route I want to edit. In this case, let's say to the train station, and here with clicking on the diamond, oh, that one I forgot. So here we are. I make the line shorter so you don't have service here. As you see here, by copying the line route, all the runtimes has been taken from the other line, which is going between these stops, meaning that I don't need to adjust or recalculate or input the service time runtime. Again, here it is automatically taken from the existing network, which is running between the stops. For the schedule, I have already divided timetable to Monday and Tuesday to Sunday. So this service is available only on Monday and not Tuesday to Sunday. So I just need to delete it. And then I can create the opposite direction and check if the created stop sequence is suitable for what I had imagined. I can remove some stops that which do not belong to the line route here. And then again, I have taken automatically the runtimes, existing runtimes here. Here we are. So by the schedule, it's this, the schedule is automatically copied. What I need is to go to the other line route and define it in a way that I have this service Tuesday to Sunday, but not on Monday, because on Monday I have the shorter route. Okay, the same for outbound. So let's see, I have the long route for Tuesday to Sunday and the shorter one only on Monday. And by this, I can calculate the ridership again and see the effect of the changes on Monday especially. I can select only Monday. I can have the total passenger per day over average. All right, the calculation is there. Now, I think for the result, we can also compare it the scenario, basic scenario that we had. Okay, what you can see here comparing to the basic scenario that we had on Monday, you can see that the number of passenger kilometer has been decreased, whereas the number of passenger and passenger kilometers on T2 and T3 has been increased. That's because that people are taking these options rather than the SP line. And also B27, you can see the number of passengers. If we go to the services, you can see why is the reason? The reason is that people traveling, if you remember here, we had passengers traveling from the south to the train station. So people need to transfer and take the B27 from Ghanisha Platz to the train station. We can check it in the detail. If you see that, you can see exactly Ghanisha Platz and main train station. We have passengers taking exactly this section. So what we can do is that first of all, we can check the connectivity at this stop if it's adequate and convenient for the passengers to travel and transfer at this stop. For this, we use the connection analysis connections. And here you can see in a nice diagram, two lines, all lines crossing this stop and then can figure if people have enough time to transfer. Here in this example, for example, people arrive at 6:49 and can go to the south in 5 minutes or in 8 minutes. You can adjust the arrival time at this specific stop, just clicking on the dots here, and then you can say if you want to change your schedule so that the people don't need to wait, or you can increase the transfer time so that in case of delay, people have time to come. This just enough to, let's say, for example, 44. You can see that the timetable has been adjusted and can do the improvements for the customers. All right, let's go back again to the indicators that we had. And what you can see here is that many people are taking also T2 as an option, and they are taking in between main train station and Vogelweide, and also on the other direction, people are taking it from Moskauer Straße to main train station. So let's see, where is Moskauer Straße? Moskauer Straße is located here, meaning that many people are traveling to this point, and then from this point they might walk to the south. So what we could do is that to make the detour more convenient, or alternative, we can extend the line so that the people can go to the south easily. For that, I'm creating another duplicate T2. Okay, I'm already in the scenario. Now I extend T2 a bit so that we can reach Veszpréma Straße, and the same for the other direction. All right. So what we can do is that we can run the calculation again and see how is the effect of the changes in ridership. Okay, the result is there. Let's see what are the differences between the construction scenario that we had and the origin scenario that we had and the extension of the T2. All right, so this is a construction one. Let's go to the indicators, compare it with the indicator we have on Monday here, especially 42. Here we have 117,000 passenger kilometers, whereas we had here 90,000. On the other hand, B27 from 4,000 has been decreased to 295, meaning that people can travel directly and it's more convenient for them to take T2. All right, we can have also look at the detail in the ridership for T2, and then here you see that people from the main station are traveling to Veszpréma Straße and taking off there directly. Some of them are taking off at Vogelweide. Okay, let's have a look to see where it is and why people are transferring there. Okay, that's obvious. So people might take also from T2 this direction, go probably with tram T3 to the north, or directly to the main station. So once you have done the changes, you can also have nice map print from it. You can select a nice area. You want to show the changes to the passengers, show the extension. For that, we have the export functionality. I'm going to export and selecting an area. Here you can choose the area. All right, and then we confirm it. And you can see that you can choose lines that you want to show. You can show all the stop points with their names, or maybe you want to show some specific stops that you want to have focus on. And you can choose if you want to show some lines or not. And you can also import from the other scenarios, like here we have T2, the extension of T2 here. You can choose if you want to show one direction or two direction. So, and then you can have a preview from it. Choose the detail level you want to export. And here you see you can beautifully show the changes, show the legend, give appropriate name for that. And export your PNG file to communicate it with passengers via website or social media. You can just post it in the social media. Okay, what else you can do? Let's go back to T2 scenario. Once you have decided that you have extension, for example, here, you can also check the availability of the vehicle, and if you have higher ridership, you can change the vehicle in the way that you have bigger or smaller vehicles. For that, we have vehicle types. You can see under each transport system, you can have different vehicles. I'm going to define a new, and let's say tram type 2 for T2, and you can have dedicated cost for that. And then you can allocate this vehicle type to the transport system. All right. And if you go back to your T2, to the vehicles that you have, you can choose for specific time or schedule if you want to have tram type 2, and then you will have a very beautiful overview of the costs that are affected by changing the vehicle type.
Thank you very much for attending this session. Why don't you try it yourself?